Hey guys, thanks for joining this tutorial. Today we're going to talk about events in Solidity. First I'd like to take a look at some of the key features of events in Solidity, and then we'll write a very simple smart contract deployed to the Sepolia test network and take a look at the event log on Etherscan. So why do we actually need events? Well, as we know, state-changing smart contract functions cannot return any values. And when they are called from an externally owned address, they return a transaction hash. However, we still need a way to provide important data regarding that function call to the outside world, for example to a Web3 application. And that's exactly what events allow us to do. So when we emit an event in a smart contract function, the specified data is written to the transaction log. The transaction log is a specific data structure on the blockchain that's associated with the address of our smart contract. The transaction log also acts as a cheap data storage on the blockchain. So storing data in a state variable is very expensive. On the other hand, emitting an event and storing the data in the transaction log is relatively cheap. It's also important to note that the transaction log cannot be accessed from within the smart contract. A client application can subscribe and listen to events, and it's also possible to query the transaction log for specific events using libraries like Web3.js or Etherscan. And a common use case is to listen to specific events and to update the user interface accordingly. When we declare an event in our smart contract, we can specify a list of arguments that should be stored in the transaction log. And up to 3 of those arguments can be labeled with the indexed keyword, which means those arguments are searchable. So this actually means a client application can later search for logs that contain, for example, a specific deposit address. Also, index parameters are stored on a specific location in the transaction log, which is called topics. Each topic is limited to 32 bytes and all other parameters are encoded and stored on the data section of the transaction log. So in the transaction log there are actually 2 sections. One for the topics, which are all our indexed arguments, and the other one the data section for all other arguments that are not indexed. And as we see in a minute in our example, the event signature, which is the event name with a list of the arguments, is also stored in the transaction log as a topic. Okay, so let's take a look at a very simple smart contract. Our contract contains a private state variable balances and a public function deposit that allows users to deposit funds to our contract. So in order to inform the outside world, for example a Web3 application, whenever a successful deposit has happened, we need to emit an event. In order to emit an event, we first have to declare the event. So we just specify an event, we call it a deposit. And let's say we log the address of the user who deposits the funds. We also log the amount, which is an unsigned integer. And we could also log the time whenever the deposit occurred. Okay, so now we have an event we can use in all our functions. Whenever we want to emit an event, we just use the emit keyword, specify the event, deposit, and we provide all our arguments. So the first is the user, which is the message sender. The second is the amount, which is the message value, and the time whenever the deposit occurred, which would be the block timestamp. Okay, that's it pretty much. Now, we also learned about indexed arguments. An indexed argument means that we can later on search for specific event logs. So if you use indexed here on the user, we could search in our client application, for example, for a specific address and get all the deposits for this address. Okay, so let's give it a try. We deploy the contract, and we actually deploy it to the Sepolia test network. So we select here, injected provider MetaMask. Okay, we confirm the deployment transaction in MetaMask. MetaMask is set to the Sepolia test network. So when you do this, make sure you have some test ether. Okay, now we wait a few seconds. Okay, this was quite fast. Now we have our event. Example. Let's call the function deposit. It's a payable function, so we provide some ETH because we have a condition. The value must be bigger than 0. Doesn't matter, we can provide a small amount. Let's say 1 way. Should be enough just to test our function. And we click deposit. What happens when we click deposit? Okay, we pass the first condition, it's fine. We update the balances, the private state variable, and we emit an event with information of the message sender, which will be the address we have selected here, the message value, which will be the value we specify here, and the current block timestamp, which is just a Unix timestamp. Okay, let's call the deposit function. We confirm the transaction in MetaMask. Okay, let's wait a few seconds. We get a transaction and we can check it on Etherscan. Click on View in Etherscan. Okay, transaction is indexing, so let's wait a few more seconds. Okay, great. We have a successful transaction and we have exactly 1 log. Let's take a look at this. Okay, here we have the address of our contract, the contract we just deployed, and we actually have 2 sections, topics and data. Now, as we learned, we have different types of data. Let's take a look again at our smart contract and at the event. We have 1 event, deposit, with 3 arguments. User, which is indexed. The indexed information will be stored in a topic. And then we have the amount and the time, which are just normal data that are not indexed, and they will be stored in the data location. So here we have the amount, which is the first argument, which is exactly 1 way. It's a 32 byte word, prefixed with zeros. And the second is the timestamp, which is just the value provided by a block timestamp. And then we have 2 topics. Why do we actually have 2 topics? Well, we should only have 1. We have 1 index parameter, the user. The user, which is our address, which ends with 2803. That's the value we can see in topic number 1, 2803. And the first topic is actually the signature of our event, which is basically the hash of the signature. The signature is just the name of the event, deposit, and the types we provided. So this would be something like this. Check 256 of deposit, and then all the different types. The first type is an address. The second type is an amount. No, sorry, it's an unsigned integer. And it's important to specify 256 because uint is an alias for uint 256, and the second is again uint 256. Okay. When you take the catcher cache of the byte representation of this signature, you get exactly this value. And that value is always topic 0. because in our front-end application, we may have different events, and we may say, okay, I want to search all events of this type, deposit with this argument list. We could have other events, and then we would have other topics here. Okay, so that's it pretty much for the events. Thank you very much for watching, and I see you in the next video. Bye bye.